Okay, so we were doing Tyndall effect, and I was telling you that this experiment you can do it in your homes. What you should do is take a tumbler which is full of plain water, and then what you should do is try and flash a torch on it, right? When you flash a torch, you will not be able to see the beam of light because it's a plain water, right? And there are no particles to split the light. But after some time, what you do is you take another glass tumbler and add some milk in it and place the tumbler next to the first tumbler. Okay, now you will see that when you look through the second glass in which you have added milk, you will be able to clearly make out the path of the light. You will be able to clearly make out the path of the torch light that you're flashing on the. Why will you see this path is because in the second tumbler, when you've added milk, so now there are particles, there are milk particles, there are suspended particles, in the water. So these particles are going to scatter the torch light which you're flashing. So every particle is actually throwing showing a torch. Every particle is actually scattering the light here, right? Which light? The torch light that you are flashing. Okay, so you will be able to clearly make out the path of the light. Okay, so that is what we discussed. So this is Tyndall effect basically. Next is I was telling you that you will ask me, okay ma'am, how do we know whether the light is going to be scattering more or the light is going to scatter less? How do we know what is the amount of scattering which is going to take place? So to know the amount of scattering, you must understand what is Rayleigh scattering. What is Rayleigh scattering? Rayleigh scattering says that the intensity of the light, the intensity of scattering of light, which is designated by I, is inversely proportional to the fourth power of the wavelength. Is inversely proportional to the fourth power of the wavelength. What is intensity? Intensity means amount of scattering. Kitni scattering hogi? How much of light will get scattered? Will the more light will get scattered, or less amount of scattering will be there? So intensity means how much will be there. Okay, more light will get scattered, less light will get scattered. Okay, what is wavelength? Wavelength, I already told you, red light has got the maximum wavelength. So if it means that this formula says that if the wavelength is going to be more, then the intensity of the scattering is going to be less. Because they are inversely proportional. More the wavelength, lesser the intensity. Lesser the wavelength, more the intensity. So just apply this formula in case of your red light. Red light has got the maximum wavelength. So if the wavelength is going to be more, then the intensity of the scattering for the red light is going to be very less, because intensity is inversely proportional to wavelength. Now apply it in case of violet light. In the violet light, your wavelength is less, so your intensity of the scattering is going to be very, very high. Understood? So it is the Rayleigh scattering law which will decide as to how much scattering will take place, whether it will be more, whether it will be less. Okay, so you've learnt about what is scattering of the light. You know about what is Tyndall effect. You now know how can you decide or how can you define whether the scattering is going to be less or more. Okay, now next what we're going to touch up, I'll quickly just give you an introduction, and it is in the next class that we're going to study more about atmospheric pressure. So atmospheric refraction. So this you must have observed that whenever you light a small fire, just right at the top layer of just above this fire, you would see the air a little wavy, a flickering. You will see flickering of the air, basically flickering of the environment, that small little space that you have there. You will see some kind of waving effect or flickering effect, right? So why is that flickering effect taking place? That is because when you light a fire, when you light this fire here, just above this area, just above the fire, the air is actually very hot. Okay, the air is very hot. So when the air is warm, when the air is hot, what is going to happen is the air is going to rise up because it is light now. So it is going to rise up, and the air which is even above this is actually a cold air. So anything which is cold is going to come down. So what is happening? The hot air is moving up and the cold air is coming down. Now because the hot air, what is the refractive index? Hot air is rarer or denser? Hot air is very, very rarer. So here the hot air which is going up is having less refractive index, but the cold air which is coming down is denser. So there is a change in the refractive index which is taking place. When there is a change in the refractive index taking place, then the light ray, the light which is traveling, the speed is also going to change, because sometimes the light is traveling in a lighter medium, then it is traveling in a denser medium. So as the refractive index of the light is changing, the speed of the light will also change. So that's why when the light enters into our eye, we feel this waving or the flickering effect. Okay, this is known as atmospheric refraction. If you've to make you understand more, let's move on to the next slide. Sometimes, okay, this also you must have observed, it's called mirage. Okay, we call it mirage. What we do is, sometimes when we're traveling, on highways, we feel that there's a water body, a small water body right ahead on the road. But when we travel to that point, we don't see anything. We do not find any water body. Why is that so? Again, it is because of the atmospheric refraction. It's just the light which is getting refracted, which makes us feel that there is a small water body on the road. However, it is nothing. This phenomena is called as mirage. And why is it so? Because, and this will generally happen on very hot days. You must have experienced this. It will not happen on any normal or good weather or cold weather day. It will only happen in hot weather day. So when the weather are hot, when the weather is very hot, the road, the surface is also very hot. So the air just above this road, the air here, this is actually a hot air. So the hot air is actually rising up like this. Hot air is going up like this. And the cold air, which is already up, because it is cold, it is going to come down. So what is happening? There is too much of fluctuation which is happening in the atmosphere. Why? Because the refractive index is different now. Hot air will have, it is rarer, cold air is denser. So light is actually entering from this cold air, then hot air, and then it is actually entering into our eyes. So when the light enters, it is continuously, it will be bending. So when the light bends, and we receive the light, we feel that there is a small water body on the right in front of the path that we are actually going, on which we are going. However, there is nothing. It is basically because of the bending of the light. Why does that bending takes place? The bending takes place because of the change in the refractive index of the medium. Why does the refractive index changes? Because at one level there is hot air, and at other level there is cold air. So from hot to cold, cold to hot, the light keeps bending. So that's why we perceive that there this is phenomena of mirage. Okay, I think this much is enough for the day. In the next class, probably we'll look at some of the applications of atmospheric refraction. We'll understand as to what is atmospheric refraction and why